This video demonstrates how to simulate by linking imported CAD data with a control program using MELSOFT Gemini, using an example of an XY table. In this demonstration, an XY table is controlled by a simple motion module and is operated by synchronizing the current value of each axis with the XY table on Gemini. The 3D model used this time has 4 movable parts. The component 1 moves along the x-axis, and component 2 moves along the y-axis, both controlled by the simple motion module. The component 3 moves along the z-axis and is controlled by the on-off signals. The component 4 moves linked to the movement of the component 2 and rotates around the center of the circle. This section explains how to import a 3D model. Click Geometry, and a file selection window will appear. Select the 3D CAD file to be used, and click Open. Import Model window will appear. If the coordinate system differs between the 3D CAD system used in Gemini, change the up axis setting. For the model for this demonstration, set up axis to -x. Click Import to import the 3D CAD data. This is the end of the explanation of how to import a 3D model. This section explains how to extract movable components and set up the mechanism. Configure the settings for the X, Y, and Z axes respectively. First, set the mechanism for components that move along the x-axis. Select the Modeling tab, hold down the Control key, and select the components that move along the x-axis. After selecting the movable components, right-click and select Extract and Extract Link. Link_1 is added to Component Graph. While Link_1 is selected, set Joint Type in the Link Properties window to Translational. Specify Rotational for rotational motion, Translational for linear motion, or Rotational, Translational Follower for rotational or linear motion linked to the momentum of another component. After setting Joint Type, specify the direction of motion by axis. Since the motion direction of Link_1 is +x, set it to +x. The X, Y, and Z axes and plus direction and minus direction for the selected link can be checked with the arrows enclosed in red. Red indicates the x-axis, green indicates the y-axis, and blue indicates the z-axis. Each arrow direction is plus direction. Select New Servo Controller for controller and confirm that Servo Controller has been added to Behaviors in Component Graph. Measure the motion range and set movable range. Select the Modeling tab, Tools and Measure. Select the start and end points of the motion along the x-axis and measure the distance. The maximum movable range is 900 millimeters. Enter 0 in min limit and 900 measured value in max limit. After the setting, move the movable component. Select Interact and drag the Link_1 component along the x-axis to confirm that it moves linearly. When the component moves beyond the movable range, an exclamation mark will be displayed on J1 in the Link Properties window. By selecting the Program tab and Limits, and checking Stop at Limits, the motion can be limited to within the movable range. Next, set the mechanism for components that move along the y-axis. In the same way as for the x-axis, select the components that move along the y-axis and click Extract Link. Link_2 is added to Component Graph. While link_2 is selected, set joint type in the Link Properties window to Translational and Axis to +Y. Select New Servo Controller for Controller, and confirm that Servo Controller _2 has been added in Component Graph. Since the motion range is the same as that of link_1, enter 0 in min limit and 900 in max limit. After the setting, move the movable component. Select Interact and drag the link_2 component along the y-axis to confirm that it moves linearly. The settings up to this point are the same as the previous one. In this state, even if link_1 is dragged, link_2 will not follow it. To make link_2 follow link_1, drag and drop link_2 into link_1 in Component Graph. Next, set the mechanism for components that move along the z-axis. In the same way as for the x-axis and y-axis, select the components that move along the z-axis and click Extract Link. Link_3 is added to Component Graph. While link_3 is selected, set joint type in the Link Properties window to Translational and Axis to -Z. Select New Servo Controller for Controller, and confirm that Servo Controller _3 has been added in Component Graph. Since the motion range is 100 mm, enter 0 in min limit and 100 in max limit. Drag and drop link_3 into link_2 in Component Graph. Finally, set the mechanism for the component in orange that performs the rotational motion. Click Move. If the link setting is configured in the same way as the components previously explained, the component will rotate around the origin of the XY table, so change the center of the rotation. Select link_2 and select Create Link in the Modeling tab. Link_4 will be created as the child hierarchy of link_2 in Component Graph. While link_4 is selected, select Snap in the Modeling tab, and click on the position to be the center of the rotation of the component. Confirm that the offset value is entered in offset in the Link Properties window. To make the component move linked to the y-axis direction motion, set joint type to Rotational Follower and Axis to -Z. Set the driver to J2, which has been specified in link_2, the component that moves along the y-axis. To link the component to link_4, select the component in the lower area of Component Graph and drag and drop it into link_4 while holding down the Shift key. Select Interact and drag the components to check that the rotational motion is linked to the y-axis direction motion. This is the end of the explanation of extraction of movable components and mechanism settings.